Hello everyone. Today we're going to talk about subnetting and switching. Go through subnetting and we will also learn something about switching. Okay. Before moving to the advanced concepts such as VLANs and the other advanced topics, I will first start with the subnetting. Okay. So what is a subnet? What's subnetting and what's the purpose of subnet? Okay, basically subnet is a way to divide a network into subnetworks. Okay, to break one network to subnet into different networks. Okay, to make it to a separate broadcast domain. Okay, like let's say we have let me show you. The formal definition of subnetting. Subnetwork. Okay, I mean, even the name says subnetwork, right? So what's a subnet? So let me show you now here. Okay, this is a good diagram. Look at this. Okay, look at this. This is a router. Okay, this is a This is a network, a switch, and 2 and 4 users inside the subnet. Okay, they are on a separate subnet. Okay, they are also here. They are on a separate subnet. Okay. Here they are on a separate subnet. Here they are on a separate subnet. Yeah. So keep in mind they will not be able to see each other, right? Because they are on a different broadcast domain, broadcast network with one network. Okay. So this is basically subnetting, dividing a network into multiple smaller networks, subnets. Okay, for security, for performance, and all of that. Right. So let's talk about the ways. There are 2 types of subnetting, classful and classless. Okay, this is classful subnet. Okay, there is class A, for example. Class A, this is class A. It goes from 0 up to 127. Okay, 0 up to 127. Okay, and class B goes from 128 up to 191. 128 up to 191. Okay, and class C 193 to 193. So what this number means, let's say there is an IP address. Okay, this is 192.168.1.8. Okay, this is an IP address. Okay, this one is an IP address, right? IP address. Okay. So the first 3 are the network bits. Okay, this is the host bit. Okay, and there is so we can So basically, when we say, like, for example, 192, basically it is going to be in class C, right? This is between 192 and 223, right? So for example, let's say we have a company. Okay, we have a company and we have 5 PCs inside this company. Okay, so which one should we use? Class C, Class B, or Class A? We'll use Class C because it's the lowest, right? It supports up to 256 devices. Okay, if we use Class B, it will be 65,000 hosts, right? It's more than we need. Okay, if we use Class A, it's 16 million. It's more than we need also. So the lowest we can use is 256. This one, Class C. Okay, so we use Class C. Okay, based on our need. So, but there is an issue with classful address. Even if we use Class C now, if you notice, we only need 5, right? We only need 5. We need only 5 5 addresses, right? But with class C, we have 256 total usable total addresses. It's too much for our need, more than we need, right? So if we only use 5, 251 will be wasted, right? So this is the problem with classful addressing. I don't want to talk more about this because this is actually not used anymore. This is only for theory. Okay, classful is not longer used because it wastes IP address. In the real world, it's not used anymore. Okay, this is class D 224.239. It's used for multicast. Yeah, classful address is for theory only. Keep in mind this one. Subnetting is always classless in real networks. Okay, so basically, what you need to know is class A is from 0 to 127. Okay, class B, and it supports up to 16 million. Class B 128 to 191, 650, and class C this is. Okay, so let's go to the main topic, the most important part, which is classless IPv4 subnet mask. Okay, CIDR. Okay, so what does it mean? Okay, it means that we can have we can have the as many as needed. We can have addresses that we need, less wasted addresses. Okay, so supports VLCM is like for the subnet mask. So subnet mask also, we need to know that this is subnet mask. Let's say we have 192.168.1.0, right? This is the IP address. Okay, so it has to have a subnet mask. Let's say this is the subnet mask, 255.255.255.0. Okay, this is, we call it /24. Okay, this is the subnet mask for this IP. We have to, every IP should have a subnet mask, right? Like, let me show you in here, for example. Okay, let me go through the IP address. Let's just put here 192.168.1.110, right? You see, you have entered an address that is missing a subnet mask. Please add a subnet mask. Subnet mask is mandatory. Okay, or it added for us automatically. It chose the class C. So it shows the 255.255.255/24 address. Okay. Obviously, this can be changed as needed. We can use also. There are different. Now this is fixed. Okay. Yeah, fixed mask. We have 3 masks we can use only in classful addresses, but in classless we will have variable length. It will be we can choose different. Like I can choose 26. I can have 30. As I can have different types of masks. Basically, that's the point of mask, and it has to be represented in a dotted decimal like this dot, and yeah, and basically 255 will be like this, and if you convert it to binary, it will be like this in ones, and yeah, 0 will be 0. So the main point that we need to understand here is that in classless, in real world environment, okay, we don't use classful, we use classless addressing. Okay, CIDR. Okay, so these are the magic numbers you have to memorize by your you have to memorize it. It has to be you have to know it by your mind. So let's say it's /25 CIDR. Here this is mask is 225.225.225.128, right? So this is the idea. So this is important. We have to, this is the things that we need to know. /25, the block size 128. /26, the block size 64, right? This you have to memorize the CIDR and the block size. You have to memorize it. So let me give you an example. Okay, this will help us with the subnetting. It will make this is the easiest, the fastest way to subnet an IP address. Okay, first step is to find the interesting octet. Okay, it's the first step. Okay, the interesting octet is the first octet that's not 255. Okay, so here, then for example here, what's the interesting octet? It's this one, right? The fourth octet, right? This one, 192, because this is not 255, right? So the fourth octet is the interesting octet. Step 3, list network address. Skip counting. So yeah, now what we will do, we will go to the, we'll see this one, /26, right? This is this tells us, we can go to the table /26. What's the block size of /26? It's 64. Here it's saying 64. Okay, 64. So what we will do is that since we know the block size, so automatically we will say 0. We'll start from 0 up to 64. Okay, then 64 plus 64 is 128. 128 plus 64 is 192. Okay, so this 4 are our network addresses. Let me show you like this. So 0 plus 64 is this. Okay, 64 plus 64 is 128, right? Plus 64. The reason we are using 64 is because it's the block size. Okay, then find the broadcast address. Super fast. Okay, let me tell you the next network. Okay, so the broadcast address is basically the one before the, for example, in the first network. Okay, so the first network, for example, this is the first network, right? Let me write for you the first network. The first network will be like this: 168.168.10.0, right? From this to 192.168 and .10.63. So this is going to be the 64. Okay, so this is going to be the first network, right? Our first network. Okay, so the last network, okay, we'll ignore. Okay, and we will take this one, this -1, the next network -1. It will be the broadcast. This will be the next network. Next network will start like this: 192.168.10.64 from 192.168.10.128. Okay, this is how we will do the network. So then we'll find the host range. Okay, the first hop, network +1. Okay, find subnet for. So this is the fastest way to subnet. Okay, we find the subnet mask, which is 26, right? So 26. What's the block size? 64. The block size is 64, and the network number will be 0, 64, 128, and 192. So we will check where is 130 here. This one, for example, 130. Where is it located? It's between 128 and 191. Between here, between this and this. and it will be on the last network. No, it will be on the before the last network, because here it will be here, right, on this network. So we'll put no 103, no 130 will be between here, between the and the last network. It will be between 129 and 190. Okay, so then we can see the total hosts. We have 62. Subnet, yeah, basically that's the idea of subnetting. Okay, for example, you may be asked which subnet does 192.168.1.77 and 7 belongs to. Okay, so what you will do, you will go to the table, you will check /27, the block size is 32, right? So خلاص, we will see that we'll check here 0, 32, 32 plus 32, 64, 64 plus 32 is 96. So we have how many networks? 4, because yeah, let's see if it is. Yeah, so this is the, so we can go on, but we stopped here because we only need this one, right? 77. We need to find where is 70, in which network is 77 located. Okay, so it must be between 64 and 96, right? So it will be on the last network. It will be between on the 95, like this. Yeah, broadcast 95, network 64. It will be here. It will falls between 64 and 95. So this is how we actually subnet. Okay, I showed you this because this is the easiest way, the fastest way to do subnetting. Okay, this you have to memorize it. You have to memorize this way and try subnetting at home. So yeah, so you can see by yourself how many hosts you have. For example, let's say we only have 4 PCs. We can use /30, right? We have only 2. We can use /32. We have only, let's say in our company we have 30 PCs. Okay, I could use this one /27, right? Because you give me 30 and 32. Or let's say in the but this is too low, right? Because I need more, because maybe we'll add new employees or new devices for the future. We can use this one /26 and 64. So basically that's the way to do things. And this is subnetting. So, but there is one more thing that I wanted to show you other than subnetting. That's switching. Switching is it's a very important topic that I think we should try to understand it. So basically, a switch, the way it works is that let me show you. Let me show you how it is. Let me explain. Yeah, so this is switches. I explained on the previous sessions on how switching works, how a switch works, but I just want to go through it again before moving to the more advanced topic like VLANs and other things. Basically, this is what it does. Okay, now my laptop is connected to a switch, right? So a switch, my laptop has a MAC address, right? Yeah, my laptop has a MAC address. Okay, and my MAC address is already inside the switch. The switch knows my MAC address because it stores it in a table. It has a table like this. See, this is a MAC address. Okay, and this is the port. Okay, so the switch has a table of ports connected to the MAC address. Okay. This is my laptop. Okay, this is the access point. It's connected to this port. It has a mapping between the port and MAC address table. Okay, so it knows where you are, where it is. But in case it doesn't, this is what it will do. 1 second. Forward. If destination MAC is known, forward only to the port. This is unicast. We call this unicast. Okay. If destination MAC is known, if we know where to send, if it knows, for example, I send some traffic, if it knows where to send, it will send to the port. If it doesn't know, however, it will send to all ports except the incoming port, flooding. Okay, this is how it works. It will flood every port. It will ask, do you know where this MAC address is located and stuff. Okay, so it will check the destination MAC address. That's how it works. Okay, yeah. Switch prevent loop using something called STP or rapid PST. This stuff we can check it later. We'll study it on a later episode. Right now, what I need you to do is download Packet Tracer. Okay, which is great concept. Packet Tracer. Any version of Packet Tracer will do. You just need to practice Packet Tracer. Yeah, let's just okay. I think I have to log in to download this one. Okay, I will download the Packet Tracer, but I want you to download it, and I will share you the link to download the Packet Tracer, and we can start practicing hands-on on the next session. Okay, yeah, we'll go through VLANs and other advanced topics. Okay, thank you for watching, and please don't forget to subscribe, like, and all that, and see you on the next lesson.